Welcome, everyone. Today we're going to be talking about the new Artec Ray II and the newish Artec Leo. So there is a second Artec Leo that we're going to be discussing. So if you're thinking about the Artec Leo of 2 years ago, this one's going to be a little different.
A little bit powered up.
A little bit powered up, exactly. So my name's Jonathan Rodriguez. I'm one of the hardware application engineers here at GoEngineer. I'm out of the Ambler, Pennsylvania office. So for all of the Pennsylvania folks joining us, I'd probably be the one working with you directly.
And my name's Jake Wenzel. I'm an applications engineer out of Illinois. I'm right in the Chicago area. So if you're down here, let's go Chicago. I've been with GoEngineer for a couple of years now, but I've been working with PolyJet and FDM and 3D scanners for about 5 years total. So I've got a pretty good experience backlog for that.
Absolutely. Yeah. And then, of course, as I mentioned, from Artec, we have Sergey joining us. Currently, he's actually in the chat just typing away and hanging out. But Sergey, if you want to introduce yourself, certainly feel free to do it in the chat, or if you'd like, you can join us on stage too. But huge resource. Again, he's the co-founder of Artec 3D, joining us from Luxembourg. So great resource to have, and we're glad to have him here. So really quickly, who are we? GoEngineer is a one-stop shop for all things digital and manufacturing, SolidWorks, Artec 3D scanners, 3D printers, etc. A lot of resources. One thing I want to mention is we're nationwide. So Jake is in the Chicago area, I'm in the Pennsylvania area, but we have application engineers all over the country for those who are joining us from all over. So again, thank you for joining us. We have a nationwide presence, so we're certainly here to help, and there's always somebody available. Some of the highlights I wanted to mention, besides nationwide presence, is the training and support. So we provide training, we provide support from 8 a.m. to 8 p.m., covering pretty much the whole workday, as well as a YouTube channel that I'm going to highlight a ton because we have a wealth of videos on there. And when we get into some of the projects that we've done with the Ray and Leo, those are generally where you find us putzing about with some of our fun projects. We're constantly posting those to YouTube.
Mm-hmm. Yeah, we cover a wide breadth of things. We've got hardware, software, and experts in basically every discipline. So here at GoEngineer, we kind of consider ourselves an engineering one-stop shop, and we really kind of sell solutions here. So, you come for SolidWorks, you come for a 3D scanner, you come for a printer, and you stay because everybody else is here ready to support you.
Exactly. Yep. And including the Artec scanners we're going to be discussing. So Artec has a great product portfolio. As you can see here, they have 5 kind of main scanners that we're going to show, but we're only going to talk about the 2. Again, the micro for kind of your small parts up to 7 by 7 inch cubes. You have the Artec Eva, the Spider, the Leo that we're going to be highlighting, and the new Ray II. Sergey, anything you wanted to add?
Not just yet. I'd like to thank you for having me here. It's my pleasure to assist you in this webinar. I will help with the answers to any questions you might have during this presentation. So welcome to ask, and we will be glad to help.
Perfect. Thank you.
Awesome.
And again,
thanks for joining us, Sergey.
You can post those questions in the Q&A section of Goldcast. So again, we're going to be focusing on the Artec Ray II and the Leo, where they fit separately, and especially one of the cool features from Artec, how they fit well together. Right. So as I mentioned briefly, this is the new and improved Artec Leo. There was an original one. They look pretty similar, but this one is everything that one did well and just improvements everywhere. Improved accuracy, improved processing, and a host of other great features. This is an entirely wireless 3D scanner. It captures full color. Uh, Additional one of the things I wanted to highlight was the kind of internal heating mode. So one of the things we often talk about with 3D scanning is when you're going to calibrate the 3D scanner, making sure it's acclimated to your environment. And in this case, they've addressed that and added a tool to make sure that the scanner is staying in a consistent temperature and that the environment is staying as controlled as possible. Is anyone else getting feedback? Or is it just
I
me?
got a little bit.
Okay. All right. So again, this is a structured light scanner. It's completely handheld and wireless. So if you're looking to go into tight areas, if you're looking to go on the move out into the field scanning parts, this is a great tool for that. It has a battery pack with it on the bottom. The battery, if you're not using the heated mode, actually goes for about 8 hours. And then of course you can swap batteries out if you need to. So a lot of flexibility as well as having the processing power on board.
And just to pile on there, one of the really cool things about this scanner is because it's completely wireless, you can go from having it in the case to being out and scanning in a matter of seconds. You know, we're really talking like 30 seconds to open the case, power it on, and then get scanning. Another thing is it's entirely self-tracked, so you don't have any kind of targets that you need to worry about. So that 30 seconds from opening the case to powering on the scanner, you don't need to pause and start putting targets on stuff either. You just go ahead and start scanning, and it figures out exactly where it is and captures data, kind of like a breeze. Oh, John, you're muted.
Sorry, I was trying to see if the feedback was coming from me. As we're kind of talking about the temperature control here, so yes, Michael, typically with all scanning tools or just measuring tools in general, temperature variations can have an effect. And so one of the ways or one of the recommendations we always have is give the scanner, roughly 30 minutes to acclimate to its environment. But if you're having drastic temperature variations, like let's say you're going in and out of a carport or something like that. So out into snow, coming back inside, etc., where you can't really give it that time to adjust, then this may be a great tool for you to work around that. But typically the recommendation is allow the scanner and any of your measuring devices to stabilize temperature and then handle any of your calibrations that you're planning to do and then proceed with using it. So again, this is one of the ways that they've addressed those extreme edge conditions. But there's kind of two schools of thought with it. If you can give your measuring tool a chance to acclimate to the environment, that's the best way to do it.
All right, and next up, I think we got the Ray here.
Absolutely.
Artec Ray II.
All right, so now we're going in the opposite end of the spectrum. We're talking about an infrared laser scanner on a tripod, something that is automated for your medium to large parts. As you can see, the scanner's range is up to 130 meters, so excellent for capturing some massive scenes, and we have quite a few examples that we're going to show you, as well as, again, when we were talking, combining the Leo and the Ray II.
A little bit of a teaser in there in the video.
Yes, definitely. Yep. So we do have that case study of the truck in here. So the Ray II, the new and improved Ray II, is combining LiDAR and time-of-flight scanning technology. So typically when you're assessing these type of tripod scanners, you're looking at one, you're looking at the other. Artec is leveraging both. One of the things I want to highlight especially is using the GPS and a host of other sensors to help align your different scans in space. So you're not fiddling about in the software trying to get everything lined up, figuring out where each piece of the scene goes. It's handling all of that on board. So as soon as you bring it into Artec Studio, everything's already where it belongs.
Yeah, that's one of these features on this scanner that really does just feel like magic, because you plop it down, take a scan, pick it up and move it, and it knows exactly where it's moved, exactly where to put the new set of data in comparison to the old set of data.
And it does have some ingress protection, IP54, for those who are interested or maybe do more of their scanning outdoors. So this is something I had a customer already ask about once. It does have some ingress protection. We can find more information on the website, but certainly that is something to keep in mind when you're taking this outdoors and maybe some light rain or kind of dusty areas. So again, I talked about the Ray II for large scenes. This was actually Jake's project, so I'll let him speak to it a bit more, but I had never seen this before. It was Buffalo Creek Wier. And I can just say, as the guy who post-processed this file is massive. So I'll let Jake take this one away.
Yeah, so this is kind of a dam-like structure that's nearby our office here, and it was one of the first opportunities I had to go out with the Ray II and start doing some scanning. So I set this up, and you can kind of see in that right side picture just how large this area is. And I took maybe 20 scans within the course of an hour and captured that entire concrete structure plus all the surrounding areas. So the speed at which you can capture really high quality scans with the Ray is really impressive. Kind of just take it on site, let it run, and move it when it needs to. But yeah, this was kind of one of our first test scans, but you can see how it captured all of the concrete and everything in there. You can imagine if you needed to do some measurements and kind of like track maybe how the concrete was moving over time or settling or something like that, this would be an invaluable tool in order to do that.
Yeah, I will also add, if you have questions about how long does it take from training to setting this Ray II up and capturing data, this was Jake's first scan. I mean, he took this thing out, he set it up, he pressed go, and he captured. This is only a fraction of the scan data. Again, I post-processed it. This is probably about 1/5 of everything he captured. It was close to 200 million points, and the video or the file all in was about 40 gigs.
Jonathan, can I spotlight this question? Is that the share button here? Let's
Yep,
try
absolutely.
it. There we go. Yeah, so Christian asks, if the Ray uses GPS to keep track, how does it manage to know where it moves if it's indoors without any kind of GPS signal? And the answer to that is there's actually a couple different systems that are tracking. So the main way it tracks, especially indoors, is by using a visual tracking system. So I've got the Ray sitting right here next to me. But you can see we've got a bunch of cameras all over it, and I spin it around, you can see there's more cameras kind of over on these corners here. So it's these guys that will actually track the environment around you, and it's constantly recording, looking at where it's at, and it can figure out when you pick it up and move it, exactly how far, in what direction, what orientations it's changed and stuff like that. So it's a multi-part system that allows it to do that.
Absolutely, yeah, well said. So again, what we really wanted to highlight is how they work well together. The Artec Ray II and the Leo work excellent together, and it's not just a matter of, hey, Artec makes both scanners and they should be able to work. It really goes much deeper than that. You can leverage the Ray II and its host of sensors to grab the whole scene, as much data as you can possibly imagine, position itself in space as you move the tripod, and then come back with the Leo to grab those fine details. And instead of relying on any tricks or proper positioning or just knowing how to fiddle around the software to align the Artec Leo scans, you can just bring them into your session and align them using the Artec Ray. So the Ray is kind of handling your volumetric accuracy and your alignment and grabbing most of the data, and the Leo is going to allow you to go into those fine areas and grab that additional information if you need it.
Yeah, this has a couple different benefits. So, I mean, the first thing is obviously you can go in and scan high detail areas and then arrange them as you need within a scene. So if you're trying to figure out where different like utilities run, imagine you have like wire or conduit or HVAC or something like that, you can kind of track them from one area of interest to another and then use the Ray to figure out exactly where all of those different kind of connections are going to have to physically exist. You want to go one more down?
Yep.
Oh.
School's over.
Yeah, I think it's yelling at me, the battery, but I'll take care of that in a sec. So another way that you can use this is just, capturing kind of like high detail areas and then large spaces that you can arrange those high detail areas in, or high detail objects really. So setting up a digital twin is something that these systems really kind of excel at, because you can just capture the machines as you might have on your manufacturing floor, exactly as they are. So you have the correct scale, you have the correct size and all of that. And then you can use the Ray to capture the space around them. And once you have those two pieces of data, it allows you to take those machines, pick them up, move them, and just kind of digitally arrange them, figure out exactly what the next like best orientation arrangement is, and take all of these different things into consideration that it would just be very hard to do without having, a complete data set basically.
Absolutely. And this tool is invaluable for us, especially as we talk to customers on the printer side about outfitting a space, being able to go in with the Ray, potentially grab the whole scene, grab some of the fine features with the Leo, and be able to say, hey, here's your total space. How do we arrange things to optimize it? Where do your post-processing equipment go? Where does some of the tanks have to go if you have to pipe air into the machine, etc. So this can be a very good use for this if you're doing factory planning. So again, we want to highlight that with the Leo, you can go in, capture those critical details in higher fidelity, higher resolution with color, so that you're combining the best of both worlds. You have all your alignments with the Ray. You don't have to lose your bearings. You can align to that information, as well as you can grab more than you ever need. So the big thing is going on site, having maybe a few hours to take your measurements, and instead of grabbing what you think you need, you can grab all of it. So you're back in the office, you're processing this data, you're grabbing the measurements you need, and you go, hey, you know what? It'd be really great if we measured this. It's probably there. The Ray, with its automated functionality, is going to grab more information than you'll ever need, just like that Buffalo Creek Wier. And then it's just a matter of, okay, what information do we need to grab from this? And then again, going in with the Leo to grab that high definition.
Yeah, another cool well, we'll get into the rail yard in just a sec, but another cool thing I wanted to mention with using the Ray to kind of capture data while you're scanning with the Leo as well is that it captures contextual information. So even if your area of interest is just what you're looking at with the Leo, and it's, maybe you're doing some kind of reverse engineering, or you got to build something that fits up to whatever you're scanning with the Leo, scopes of projects change sometimes. And if you're going onto a customer site to collect data, a lot of the times that's going to be the only option or the only time that you have to actually go to that site, collect the data. You're not going to be able to get back on site to do that again. So having the Ray kind of just pick up data around gives you a lot more flexibility. Even if it's not the highest quality data like you would get with the Leo, it still just gives you a lot more flexibility in how you approach different situations, especially as scopes of projects evolve and become larger than you might have first expected.
Absolutely, that's a great point. There's often times where we go on site on the scanning services side and we have to we kind of have our focus. We're like, okay, we're going to grab these key features, scan them, but it's just as easy to scan more than you need than it is to just focus on an area. The scanner's already grabbing all that data. So then again, it's just a matter of how do we leverage that later. And so we can focus in on some of those features that we needed, but then we have that contextual data to say, okay, well, this is how it's positioned in space. This is how it's interacting with the rest of the assembly or fitting in this factory layout. And then we can kind of expand our scope and address some of that other information that we have available to us. Actually, one of our case studies highlights this one really well. So this is actually a scan that Artec provided us with. They were gracious enough to share it with us. It's a rail yard, so a big outdoor space with a lot of different things going on, your train cars, buildings, etc. And you can see it's grabbing a lot of detail. And especially in some of these later photos, we see what the Artec Ray is able to capture. And again, I want everybody to keep in mind when we're looking at some of these photos that we're scanning this from very far away. So this level of detail from 50 meters out is absolutely incredible. And then of course, with the Leo, we can go back in and grab something a little higher resolution, a closer standoff distance, something where we need to focus in on, and then incorporate that with the Ray.
Yeah, real quick, I'm not sure if we mentioned the range of the Ray scanner, but you can scan things up to 130 meters away. It's going to be able to capture data from. There is kind of a gradient of accuracy that goes along with that. So if you scan things closer, you're going to have a higher accuracy, a higher resolution mesh, but up to 130 meters. So it's just a ridiculous distance that you can scan from.
Yes, absolutely. When we talk about contextual data, not only are you getting the park that you're scanning, you're getting the parking lot out and some of the cars too. So, and then of course, I want to especially highlight that this is not just something that the Leo and the Ray work nice together because they're both from Artec. This is really a uh, decision that was made to make them work well together and to give you a lot of functionality that you don't necessarily have with them separately. So here's actually the Artec Leo and Artec Ray data overlaid, aligned by the Artec Ray within their software. And you can combine the higher resolution version of the Artec Leo with the Ray. And they also have some really impressive smart fusion algorithms that take the best data from both. So it's not only saying, hey, this should be better and this one should be worse. It's actually looking deeper than that, measuring the error that is being introduced, and it's taking the best of both worlds. So here you can actually see the resolution from the Ray up top, as well as the resolution when you combine both systems below.
Yeah, just really take a look at some of the mechanical elements, the bits and bobs on the train, the little lever mechanism kind of in the center of the screen. You can just see that there's a much, much higher level of fidelity to the Ray scan at the bottom, or sorry, the Artec Ray and the Leo scan at the bottom. And, the kicker to that is that you still get all that same context that you have with the Ray. You know exactly where those high fidelity elements exist within the world. So if you need to make connections, further away than what the Leo can do, that all becomes possible now.
Perfectly well said. Then here's another visual. Again, you have the Ray II up top, and then the Ray II and the Artec Leo below. What immediately stood out to me when I saw this file was just the pattern on the surfaces that were captured within the Leo. It's this like very fine kind of crossing diamond pattern that gets picked up super easy, aligned, and you just have this global kind of scanning out to 130 meters of this whole train yard, but then you have this really incredibly fine detail in the areas that you need it.
We're going to see a little bit more of a detail on that diamond pattern, I think, on the next slide.
Yeah, Absolutely,
There
we
she
are.
is. Yeah, so I mean, like the Ray is capturing a lot here, but the hardware is not designed to capture the level of detail that the Leo is. So, it's best of both worlds, bring them together.
Absolutely. Yep. And so especially if you're looking at this and you're talking or you're thinking in your mind, do I need a Ray? Do I need a Leo? Do I potentially need both? Uh, the first thing to think of is the Ray is capturing a ton of data. And for many of our customers that are looking to do factory planning or looking to do massive sites or maybe steel mills like Michael had mentioned in the chat, this may be perfectly suitable for it, and oftentimes it is. And then the Leo might be great for some of those smaller things if you're more working on those level of resolutions. But they can also be combined. And the second thing is you can certainly always reach out to us, and we can work with you directly on which one makes sense in which scenario and how you can get either the best of both worlds, or maybe you just need a Leo, maybe you need a Ray. So I do want to highlight this. Oh, sorry, share this one. Yeah, Chris. So the Ray does have really fine detail as well. The way it kind of specs out on the spec sheet, and we can share that with you, is that the closer your standoff distance, the higher resolution mode you have available to you. And so what you're looking at with this railway yard is you're looking at a feature that is very far away from where the Ray was standing. So there's kind of a trailing effect or a drop off in resolution that happens when you're scanning far away, but that doesn't mean you can't move the Ray closer and get a higher resolution version of it. And then that also doesn't mean that you can't go back with the Leo as well. So it really depends on how quickly you want to capture all the data. One thing I didn't mention with Buffalo Creek Wier is that Jake actually went and did close to 20 scans to grab as much detail in as fine resolution as he could, but he also could have gotten a lot of that contextual information with, say, 5. And when you talk about the Ray 2 scanning about 5 minutes in high definition mode autonomously, you can grab a lot of data very quickly, but you can also go back and add more.
Mhm. Yeah, so real quick, just to add some numbers to that, we're talking a resolution of 3 millimeters under 10 meters. That's the highest resolution that you're going to get off the Ray.
Mhm. Perfect. Yep.
Yeah, so here's a little Q&A break. I know you guys have been throwing stuff into chat, and let's see, we've got another question here, but I just want to, welcome any questions from any direction. We're here to just kind of introduce this hardware to you guys. So if there's any basic questions about where they might be used or how it might be useful in your situation, it's all going to be beneficial to talk about and just put out there for everybody to kind of get. So feel free to throw anything in there. It's like Scott's got a question here. Scott and Jake. Let's do Jake's first. So Jake is asking, what happens if something moves during a scan? Are there ways to capture scenes with motion? First part of that question, if you scan something while it's moving, it's same kind of thing that you're going to get with most scanners. You're going to have kind of a doubling of that data. So it's going to scan the object in the first position, and then if it sees it again in a second position, it's going to recollect data in those areas as well. Second part of the question, are there ways to scan scenes with motion? There actually are. So the Artec Ray has a feature built into it called double scan, where it would actually go through and scan twice, and any kind of data that it doesn't see twice, it's going to get rid of for you. So it kind of mitigates that like motion, people moving through a scene issue. So that's obviously it's scanning twice, so it's going to double the amount of time that your scan takes. But if we're talking, 2-3 minutes for a scan, it's not too bad. It's not the end of the world.
Mhm. Yes, so well said. To tack onto that, we actually had one of our colleagues do a scan of a children's park, and he used that feature to filter them out. So he captured the whole park, but it wasn't like he went when it was closed or anything like that. It was broad daylight. There were people there. So again, our tech has thought of a way to help mitigate that. They've added this feature that allows the Ray to intuitively, remove anything that is kind of moving or not meant to be part of the scene. So let's do this one. So yes, the Leo does have a very fine resolution. One of the improvements on the Leo, let's call it 1.5, the new Leo, is that it also has an HD mode, which allows you to get much finer resolutions too. So there's a lot of options for capturing thread. It ultimately depends how big the thread is, but again, we can share some like minimum feature size documentation that can help you understand whether a thread could be properly captured or not. But we have scanned threads with the Leo.
And then I'm gonna do one more question here. I think, let's see, we've got some questions about CAD and SolidWorks. We can probably take those towards the end because that's gets kind of into reverse engineering. But let's see, we'll do Diego. Throw that up on there. Does the Leo capture any texture of the data scanned? So I think I'm interpreting this question correctly. There are kind of two definitions to the word texture. The first one is kind of just like the general definition where people are like, oh, it's got, you know, like texture. My water bottle has like you know, texture that you can feel on there. The second is texture as like an image texture. And the answer to that question is yes, it captures both of those. So the actual like shape of the object, like imagine that diamond plate that we were looking at earlier, that is geometry, and that's captured just by the 3D scanning functionality of the scanner. But the color texture is also captured, and we have some examples of scans with color in them as well. That's something that it takes a little bit more post-processing to get kind of applied to your mesh, but it is something that is collected by the Leo and also the Ray. So both of these scanners will capture color texture.
Perfectly said. There's two questions about SolidWorks that we'll kind of mention or dive deeper into at the end. But yes, the data can be simplified, and there are ways to pull it into CAD softwares like SolidWorks, but generally it's not a immediately pull your scan or mesh data into SolidWorks. This one right here, I'm going to tap Sergey mostly for this one, but my understanding of the Ray II is that in addition to GPS and altimeter and things like that, it can also measure kind of rotation or movement as it's going. And so even though the scanner might be kind of, let's say, going with waves and things like that, it should still be able to accurately scan and then position itself in space, correct?
Mm-hmm. Yeah, for that, it's
yes.
going to come down to, oh, sorry, I'll let you talk.
Yes, correct. If you want to scan the scene that is not moving in the system of coordinates of the scanner, you can scan it perfectly in spite you have some other environmental objects moving around. So the scanner will catch all the stuff, but the data of your interest won't be disturbed by things flying or moving around. The scanner will just capture some of data, which will be either automatically, if you will, or manually deleted in the data.
Mm-hmm. Yeah, so it's basically going to come down to your reference frame. So if you're scanning the barge while the scanner is on the barge, as long as everything is kind of static with relationship to each other, you're set to go. If you're trying to scan the barge as it's floating around from the shoreline, then because it's floating around and moving a little bit, that's probably going to come in noisy. I wouldn't imagine you'd have good results with that.
And I'd like to elaborate on the GPS thing. It's an additional mode to align data. Primarily, what we do, we use internal sensors that see the environment, the data itself. So first of all, there are 5 RGB cameras that work constantly, and they observe the environment. And when the scanner is doing one scan in this location, in this setup, the cameras capture the environments and they retrieve automatically, not them, but some algorithms on the scanner, on Ray scanner. They retrieve reference points, constellations of reference points specific for this setup. And then when the scanner is being moved, the cameras are capturing the movement of this constellation of reference points in the environment. So the scanner knows exact relative position of itself comparing to the previous setup. So when you move the scanner, put it down into another location, the scanner makes another scan in the system of coordinate of the previous scan. That's how we align. So first of all, the scanner uses 5 cameras working constantly, and secondly, it uses a 90F or 9-dimensional freedom sensor built in, which senses movements and inclination of the scanner. So we use different techniques together to make accurate pre-alignment of data between scans. And afterwards, when the software is retrieved from the scanner and opened in Artec Studio, which is basically our software that when you process all the data, we also do best fit for all the scans. So we also use the geometry of the scene itself and texture of the scene itself to accurately align all the data together.
Mhm.
Perfect. Thank you. And then I guess last one really quickly, Sergey, I know we talked about this one when we were in our planning meeting, but do you want to quickly address how light sensitive is the ray? How dark can it be where the scanning is done?
Yeah, with the dark condition, it's the easiest question. It doesn't affect anyhow because both scanners are active. They project their own light,
Mhm.
and they rely on that light, so they see the reflection of their own lights
Yeah.
to scan the scene.
Yeah.
Uh,
So the
Ambient light might be stressful for some scanners, but our scanners are quite stable to ambient sunlight. Specifically, Leo scanner, this handheld scanner. I personally scanned with the scanner in Africa in the desert during the day with the open skies and different direct sunlight, and it works perfectly. So it's not affected in terms of 3D geometry. Of course, texture can be overlaid, but geometry keeps intact. So for the ray scanner as well, so it can work under sunlight and it's quite stable.
Perfect. Thank you. All right. We have
All
a
right.
few
Yeah,
other
and there's
questions. Oh, good.
yeah. I was going to say the same thing. We've got some more questions. We're going to get to you guys at the end. Don't you worry. The computer specs and CAD reverse engineering type stuff we'll address in just a sec. But we're going to go ahead and look at some more scans for a sec, and then we'll get right back into it.
Yeah, here's the fun part, the projects. So this is Jake's office. Jake, do you want to tell us about your office?
Yeah, so this was another pretty early project that I took on for the Ray, and it was just it was kind of an experiment with scanning a relatively small enclosed space just to see exactly how I would get kind of the results. So if you flick us forward one more, I think I have a general slide, general picture. Yeah, so there is the back of my office, and then here these are some details on the quality of the ray. So this was scanning at the highest resolution, and for, I think somebody was asking about the quality of the ray that you can get close up. Take a look at the laptop there, and that's going to be about typical. So one thing I did with this was I didn't do any hole filling because I just kind of wanted the surface data here. But if we go a little bit forwards now, I took these scan data sets and I combined them with the Leo. So you can see, the top in the blue, we have the Artec Ray, and then in the bottom, we've got the Leo. So there's kind of a improvement in quality as you go between those.
Yeah,
There's
absolutely.
a couple more examples coming up here.
Yeah, so this one I want to absolutely mention the detail of the leaves from both of them. This impressed me greatly because I've never seen Jake's office, but I definitely have a clear visual of what it looks like. And again, just the resolution from being close range, whether with the Leo or the Ray II, in many situations, it's good enough for the Ray II. It's not something that I want to highlight. It's not a slouch when it comes to getting high resolution scans. We're getting details of some pretty small parts on his desk, as well as seeing the laptop, keyboard, even just from a color texture standpoint, getting to actually see the icons on his screen and everything else.
Yeah. So the before we flip off this slide, I just want to point out, the leaves both look pretty well. I was pretty impressed with the Artec's resolution, or the how it resolved the leaves there. I was a little bit disappointed because I wanted more of a difference between the Leo and the Ray, in fact. But if you look at some of the more like mechanical type objects on that shelf, particularly like right in the middle where you have that little like Go object, you can just compare the two of those and see that the corners come out much sharper on that. So this is kind of what we're talking about, where the Ray is great for like representing very large scale kind of like form type objects. But if you need to go in, get details, and kind of get measurements off of these objects, like in any kind of mechanical sense, you're doing reverse engineering, or you need to build something that, you know, fits that part in some capacity, that's where you just need to go to the Ray, or sorry, to the Leo, because you just need that increased level of detail.
Absolutely. Yeah, well said. Yep. I'm going to skip that one. So this is another Artec scan that was provided to us. So again, thank you to Sergey and his team. But this is a parking lot with a poor sad BMW that was taken too soon. Here you can see they've grabbed a lot of contextual data with the Ray. You can see it's grabbed everything off to the side, and just kind of visually looking at this, I could tell this was probably done in very few setups. So how long roughly do you think this would have taken, Sergey, to scan something like this with the Ray II? And I know you can see a little highlight here that the Leo, they went back in with it, but just kind of grabbing the Ray, probably set up somewhere in the center and then maybe top right. How long roughly would that take?
I would say for just Ray scan, I would four setups, 4 or 5 setups would be enough, and each setup takes roughly 2 minutes. So 5 minutes for Ray scans, and then in the middle you see it's colored differently. It was scanned. The car in the middle was scanned with Leo scanner additionally, and this scan I would say it would take 15-20 minutes, depending on your goals. I would say that this example is a good representation of car crash investigation application, or remotely it refers also to crime scene investigation application. When first of all you need to scan the evidence itself. In this case, it's a damaged car, and investigators scan the car, digitize them to see the damages on the car body, to then describe the sequence of events that happened during the crash. But also they need to scan relative position of the car to the environment, and if the accident involved other cars, which is typically the case, they want to see relative location, the relative position of the cars and other elements of the scene of the road. So in this case, you need both. Scan quite large scene, see it on one hand, and on the other hand, you need to see specific elements of the scene in higher details. And in this case, combination of the two, scanning with Ray, the large, the entire scene, and then scanning with Leo, exact elements of interest of damage. It's a good combination to get the job done.
Absolutely. Yep. Yeah, and here's a close-up of the trunk area and the busted taillight of the BMW gone back with the Leo. One of the questions that came in was the range of the Artec Leo, so it can scan up to 1.3 meters. There are some background removal tools that are quite useful for getting rid of data that you're accidentally capturing if you're going close. And of course, you can go higher resolution the closer you are to the part. So if I remember off the top of my head, it's about 0.5 meter to like 1.3 meters is the working range.
Mm-hmm. Yeah, and here's the a close-up of that bumper. And again, you know, you can just see the difference in detail that you have here. Like the Ray is great for figuring out where everything exists in space, but if you need to get any information about the surfaces that you're actually looking at, aside from just kind of location, the Leo does a great job of, you know, reconstructing those surfaces. So this is something that you could take and, you know, use for archival purposes or redesigning or measuring or stuff like that. There's plenty of things you can do with surfaces of that quality.
Absolutely. Yeah. So I'm gonna skip ahead because Jake has been kind enough to be answering questions as we're going along. Actually, you know what? I'll take a step back. So there was one question about the scanning spray. So there wasn't, to my knowledge, there was no scanning spray used in the scan for that BMW one, correct, Sergey?
You're muted.
My apologies. Not any sprays were used in this case. Sprays are only necessary when you have a very new car, brand new and very clean, and if it's too dark. In that case, uh, not always, but in some cases you might be needed to use some spray. But for normal cars, you don't need spray at all. So it's quite scannable. They're
Yep.
quite scannable.
Yeah, and to add to that, on the Leo, there is a slider for adjusting the shutter speed if you need to allow more or less light coming in.
Mhm. All right, and then before we get into the remaining case studies that we have, I just wanted to address some of the SolidWorks questions and the reverse engineering as well as the computer specs. So first off, for the computer specs, let's see here. What are the best computer specs needed for post-processing? For particularly large data sets, like what you might end up with the Ray II, this kind of falls into the category that more is better. More RAM is going to make things go faster, allow you to process larger data sets, more powerful CPU, more powerful GPU. I threw in a link to like the recommended specs, but you can definitely exceed that if you need something better. As for our reverse engineering, let's see, SolidWorks. What options are available to pull into CAD models? Are available to pull in CAD models into 3D scans. So we're going backwards, actually. Interesting. I thought this was a reverse engineering question. Jonathan, you have a thought on this?
Yes. So if you are pulling a CAD reference back into 3D scans, there's quite a few tools to allow you to do that. It ultimately depends on what you're hoping to accomplish by doing that.
Mhm.
Typically, when people do something like this, it's usually an inspection question. So you have some CAD reference, you are scanning a part, you are aligning them to create some inspection report. And we do have tools for that, things like ControlX, things like Polyworks, that you can use for inspection. If you're talking about reverse engineering, then you can take your scan data with a few steps into a CAD package, either directly, or sometimes what we do is we'll do it on like an entity basis. So if we're doing pipes, we might take that extrusion straight to CAD because that's ultimately what we're looking at. We might take cross sections, we might take spherical shapes, a whole bunch of other things. Within Artec software, they have a lot of geometric shapes that can be best fit aligned to the scan data, and that could be exported out as a kind of CAD-esque file.
Mhm. Yeah, so the software that you use to post-process your scan, you can start off with, we have our like kind of the proprietary software that Artec makes and that Creaform makes and that, the manufacturers of the scanners will provide. And those are great for a lot of different functions, but depending on what you're doing, if you're doing, 100 reverse engineering projects a year, you might want to look into something that is designed more for reverse engineering. So the great thing about these scanners is they're all software agnostic. This is a question that we get all the time, is like, what software do I need for my scanner? And it really comes down to, what are you trying to do with the scanner? So oftentimes we'll consult with customers, try to figure out exactly what they're doing and steer them towards the correct piece of software. So if that's something that you think you're, kind of ready to dive into, that's definitely worth a call to us. We handle that kind of stuff all the time, and it really is just on a case-by-case basis. You got to figure out what's going to fit for your situation the best.
And then to take that a step further, without any post-processing, the Leo is giving you a mesh file like an STL or an OBJ. The Ray II is going to give you a point cloud. Within Artec Studio, you can triangulate that point cloud to also create a mesh out of the scan data. And so that's typically what you're doing. When you go into a reverse engineering workflow, then you can either clean up that STL, you can convert it to a step file, whether it's auto surface or kind of geometrically created, or you can go all the way to a full CAD format, like if you're doing a standard SolidWorks file or some of the other CAD packages. But the further you go into like towards a CAD package, the more reverse engineering is involved.
Yeah.
And then one recommendation for doing so, we had this question come up before, is you do want to simplify the data. So the Ray 2 especially is going to capture a lot of similar data,
Oh, yeah.
especially as you move it to different positions. Again, you're scanning 130 meters out, so you have a lot of overlap. And so one of the first steps is to triangulate those files, and then what we call decimate, which is lower the resolution in areas you don't need it. So for example, if we go back to that dam, the Wier picture that Jake had created, that file, we might not need high resolution everywhere, just in specific areas. So that was actually a part that when I was post-processing it, I was able to decimate it up to 50%. So we took a file that was, or one scan that was roughly 15 million points, and I could drop it to 7.5 because we didn't need that much detail. And doing that makes it a lot easier on your computer. It also makes it a lot easier when you go to reverse engineer a part to go into something like SolidWorks. All right. We have one other question I think that we did not address, which is about scanning whole cars. And I got one for you. So this is a Leo only project, but anybody who knows me well, anytime you stick an engine that's way too big and powerful for a vehicle into a vehicle that would be great with it, I'm in. So a van with a Hellcat engine, 700 horsepower, I am absolutely in. One of the interesting things about this case study was they said specifically it took them what was it like? It took 4 years for them to buy a $4,000 3D printer, but it took them 15 minutes to buy a Leo. And that just tells you the power of this as a tool for reverse engineering and digitizing data. And another thing they mentioned was capturing more than they needed. He said, we go on site, we scan cars to do custom modifications to. He's like, but years down the line, somebody will say, hey, do you have this part? He goes into the file, he reverse engineers that one little component that he just overlooked because he didn't need, but the data still exists. And so they were able to capture more than they've ever needed and also reverse engineer this Metro and eventually outfit it for a Hellcat engine using the Artec Leo. What I will add, oh, sorry. What I will add to the question is that the Artec Leo, or when you're evaluating the EVA versus a space fighter versus the Leo, you're really evaluating what size of parts you're looking for and how small of an area you have to go into, how high of a resolution you need. So for automotive things, typically where your tolerances aren't super high, the Leo is a perfect tool for grabbing all of the data very easily. An extension of that is actually this one right here. So this was kind of an optimization project where they ended up using the Leo and the Ray 2. So much bigger vehicle, a lot more vehicles, and they were looking to 3D scan and digitize this whole truck to do computational fluid dynamics testing for optimization. And so again, they were able to capture most of the data they needed with the Ray 2, but then go in for those fine features with the Leo. Things like the grill that are very important for optimization, they went in with the Leo.
All right, we've got like 4 minutes left here. Let's see.
Yep.
Um,
Yeah.
Cost on both systems, software package that gives me the trouble inspection, reverse engineering together.
Yep. So I can take this one really quickly. If you're looking for one company to provide reverse engineering and inspection, Geomagic, DesignX, and ControlX do have both of those, or it can handle both of those. Artec Studio has some reverse engineering tools within it, so that's certainly something. Reach out to us. We can give you a demo of the software, show what's available in there, and if you need something beyond that, we might recommend something like DesignX and ControlX. DesignX for reverse engineering, ControlX for the inspection, and they're both from Geomagic.
Regarding the prices, I always say I am the technical guy. I'm not the sales guy, so I don't do numbers. But I'll throw out ballpark. I think the Ray is around 88,000, and the Leo is around 40. Sound right, John?
That sounds about right. We also might have some of our sales reps hiding in the chat. So
Yeah.
if anybody has some numbers off the top of their head, things always fluctuate, whether there's promos and other things going on. So certainly the best way is to reach out, let the sales rep get with you and work on the quote and give you a better idea of what the whole thing would cost. But fortunately, we don't have to do paperwork on the tech side.
All right. One more question here. Let's see. Throw that up on the screen. Is there a software package that gives me the metrology inspection and
I
reverse
grabbed that one.
engineering together? Oh, you did?
Yep.
I'm sorry. I'm not paying attention.
It's okay. It's okay. Yeah. Last thing I want to add before we go in the last 20 seconds is where you find more information. So our GoEngineer website, including our blogs, is where you can find a ton of information. Artec, the case studies I showed you are from artec.com/cases, so you can go check those out. Of course, our YouTube channel for both GoEngineer and Artec. I want to quickly thank Sergey for joining us and the Artec team, Kayla for helping set this up, and here's our emails, and that's it.
One more question I'm going to sneak in here because I love this. It's a great plug for us. Are the devices available for rental? We don't rent the devices, but you can rent us. We do scanning services as one of the services we provide at GoEngineer. So if you've got a project that you're interested in, or sometimes people are interested in buying scanners, kind of want to get their toes wet and see what it's all about. We do scanning services all the time. So, give us a call. We'll figure out the scope of your project and go out there and do it with you.
Absolutely. Also, we will have the Artec Leo at AMUG, so if you are there, stop by our booth, ask them for a live demo. They'd be able to show you there.
AMUG in Chicago. Come join us in Chicago, or join me.
Yes, I will not be in Chicago. Yep. Okay, I think that was everything.
Awesome. Yeah, we made it through.
All right.
All right. Thank you, everybody, for showing up. Sergey, thank you for joining us. I really appreciate that.
Thank you very much for having me. I would love to have more time, but since because we can speak about that too and their benefits for ours, but since we have only this time, it was great to have it with you. And should you guys have more questions, please contact Jonathan and Jake, and we will answer all of them. And we, Artec, will help them out as well.
Absolutely. Yep. Thank you, everyone, and have a great rest of the day.
Take care, guys. Bye.